Hello, my name is Muhammad Zulhusni bin Muhammad from Group 3, and today we will be presenting our project on the automated smart greenhouse system with a rain fill feature using Arduino. Before we proceed, let me introduce our team members. First, Muhammad Danish Daniel bin Dahlan, and second, Muhammad Amirul Sudais bin Jamil, and third is Ahmed Haitham Fadasi, and fourth, the last member is myself, Muhammad Zulhusni bin Muhammad Badrul. Our presentation will cover the following sections. First, introduction and background. Second, the flowchart of the system. And the third, component list. Fourth, circuit diagram. Fifth, the code that we use for the system. And the last part is the code demonstration. I will be presenting introduction and background, flowchart, component list, and circuit diagram. For the code that we use for the system, will be presented by Muhammad Amirul Sudais bin Jamil, and for the code demonstration will be presented by Muhammad Danish Daniel bin Dahlan and Ahmed Haitham. In Malaysia, where heavy rain is very common, managing greenhouse environment is very important. Over-irrigation can damage crops, but automation optimize conditions and prevent weather-related harm. So, our project focuses on creating a smart greenhouse system that automates irrigation, ventilation, and climate control to optimize plant growth. It uses sensors and actuators to monitor and respond to environmental conditions efficiently. The rainfall feature ensures the system adapts to unexpected weather changes by closing the greenhouse roof when rain is detected. Now, let's look at the system flowchart. It outlines how our automated greenhouse operates step by step. First, system initialization. When powered on, the system initializes by reading sensor data including soil moisture, temperature, light intensity, and heavy rain. Checking the temperature. If the temperature is high, the system activates the cooling fan DC motor for ventilation. If the temperature is normal, no action will be taken and it will move to the next condition, which is checking soil moisture level. If the soil moisture is low, the system activates the water pump to irrigate the plants, and if the soil moisture is sufficient, the system doesn't activate the water pump and proceed to the next step, which is checking the light intensity by photoresistor. If the light intensity is low, the system will turn on the LED to provide additional lighting. And if the lighting intensity is sufficient, the LED remains off. Next process is checking rain detection or rain fill feature. If rain is detected, simulated by a moisture sensor or force sensor, the system closes the greenhouse roof using the micro servo. If no rain is detected, the system will keep the roof open for natural ventilation. Next process is displaying data on LCD. The system continuously updates and displays real-time temperature, soil moisture, and light intensity readings on the LCD screen. For the last process is looping process. The system will repeat these steps continuously, ensuring that the greenhouse is always monitored and adjusted accordingly. Now, for the component list, we use a few components for our system. So, for the first component is Arduino Uno R3 to process the data and control the system. And second is soil moisture sensor to measure the soil moisture level to automate irrigation. And third, force sensor that detect pressure or weight, and fourth, the DC motor to drive the mechanical movement like ventilation or irrigation. And fifth is micro servo that will control small mechanical adjustments such as opening vents. And sixth is power supplies. We use a 12-volt power supply. Next, we also use LCD. We use LCD that size 16x2 to display the system data like temperature and soil moisture. And 8, we use LED to indicate system status or alert the users. And 9, we use NPN transistor that will act as a switch to control high power devices. And 10, we use photoresistor to measure the light intensity for automated shading or lighting. Next, we also use 220 ohm resistor that will limit current flow to protect components. And 12, we use breadboard to provide a platform for prototyping and wiring components without soldering. And 13, we use temperature sensor to monitor the greenhouse temperature for climate control. And the last, we use diode to prevent reverse current flow to protect sensitive components. So, this is our complete circuit diagram. We have labeled the circuit diagram with the numbering from the list, so all of you can refer from the list.
Hello, Assalamualaikum. My name is Muhammad Sudais, and I will explain about the code being used in our project. So first of all, the code include the necessary libraries, which is include wire.h, which the function is to enable communication with the I2C devices, Next include liquid crystal underscore I2C.h, which is the function is to control the LCD display. And next this include servo.h, which allows control of a servo motor for ventilation. So the second part of the code is about initializing components, which is liquid crystal underscore I2C LCD open bracket 0 times 20, 16,2. The components it creates an LCD object with I2C address 0 times 20, which create a servo motor object. So next number 3 in the code, number 3 component is defining sensor and actuator pins, which we define all the necessary pin and sensor and actuator, which you can see in the code, where the main part, the important part is the force sensor is used as a range sensor, which the other definition is with the name you can read in the code, which is temp sensor, light sensor, soil sensor, vent motor, water pump transistor, and growth light. Next, the number 4 is setting threshold values. We use the function constant integer to define limits for temperature, light, soil moisture, and the rain detection. Number 5, we use the function void setup function to run once at start. The function attach the servo motor to its pin and sets output pins for the water pump and light. This part of the code is initializes the LCD and the serial motor in the serial monitor. Next, the number 6 is the loop function. We use void loop function so that the system runs continuously, which the loop function starts with read the sensor values, controls ventilation, irrigation, and lighting based on sensor data. And then the last, we displays the data and waits for 2 seconds before repeating. Next, the number 7 component in this code is read temperature function. Integer read temperature is used for reads temperature sensor value, which converts it to Celsius and returns the result. And number 8 is control vent function, which manages the ventilation. We also use the void control vent integer temperature function, and also the if else, which if the temperature exceeds 30 degrees, which opens the vents. Otherwise, the vent will get closed if the system doesn't exist 30 degree. Next, number 9 is control growth light function, which manages artificial light. We use void control growth light function and also if else if function, so that the system turns on growth light if darkness lasts over 30 minutes and turns it off when there's enough natural light. And number 10, we use the control irrigation function, which manages the watering system. The function of this part of the code is to turn on the water pump if soil is dry and there's no rain. And it also includes a 5-second delay to prevent frequent switching. So the last part of the code is display status, which function shows data on LCD and serial monitor. We use void display status with integer temperature, light, and so on for everything. It clears the LCD screen and prints temperature, light, soil moisture, and rain values. Also, it prints the same data to the serial monitor for debugging. And so the summary of this code is, I would like to sum it up, which the program reads sensor values, control the vent, light, and the water pump, and displays data on an LCD. The temperature sensor controls ventilation, the light sensor manages artificial lighting, and the soil sensor controls irrigation. The system operates automatically, ensuring an optimal greenhouse environment.
Hello and good morning everyone, my name is Ahmed Ahmed, and I'm going to be talking today about the components and the wiring instructions of our circuit, and we're going to be looking at each component. Okay, let's start. The first component is the Arduino device. It's a microcontroller board, and the connections, like the wiring for the Arduino, the voltage and the ground pins are connected to the breadboard, as we can see, and ground is on. Other external components are connected depending on our code. So depending on our code, it follows our connection. And for the second device is the power supply, and this device is a piece of electronic test equipment for supplying power to our circuit. And for the connection, it has 2 wires, as we can see over here. The positive is leaded and connected to the positive terminal on the device, and the negative is connected to the ground. And after that, we have the DC motor, and it converts electric current to rotational motion. And this device, it has two wires. The positive is connected to the power, and then the negative is connected to the ground to make the motor spin. Then we have the microserve. It contains a DC motor, a controller board, and a gearbox, all inside this device. And for the wiring, it has three wires. This device is powered by connecting the power pin, which is this one, to the Arduino voltage. The ground is connected to this is the ground, is connected to any ground terminal on the Arduino over here. And the signal pins is connected to any PWM cable output on the Arduino, as we can see here on the picture, here on the circuit, sorry. Then we have this screen. It's called the LCD display screen, which display and give us output such as our readings, and it has four wires connected, like the ground, the VCC, the SDA, and the SCL, and it's connected, and it's all connected to sorry, just give me a moment. It's all connected to the breadboard. And after that, we have the force sensor. The force sensor, this device is a variable resistor that reacts to pressing. And it has two wires which connected. It has two wires, these, and often connected to the analog input of the microcontroller. And the force sensor are not polarized, means that they can be connected in either direction, so it doesn't matter. And we have the soil moisture over here. This device detects the amount of moisture present in the soil, and it has three wires: the voltage, the power, the ground, and the signal. And the power is received by connecting the voltage to the Arduino voltage terminal, and the ground is connected to any ground terminal on the Arduino, and the signal pin is connected to any analog input, as we can see over here on the Arduino. Then we have the breadboard, and the breadboard has two long rails for power and ground, and wires are held in the middle columns. A divider in the centers allows the chips to be connected to both sides, and it doesn't matter that much how like the wires are connected, but as long as you follow the codes, it should be okay and should work properly. And all the sensors are lined up and connected to the A pins, and the actors are lined up and connected to the D pins. And for this, that's gonna be all from me.
Assalamualaikum and good day. My name is Daniel. Now we move on to the simulation. So this is the whole circuit, the automated greenhouse system circuit. I'm sure by now Ahmed has mentioned all the component list and explained to you all of the wiring instructions. So let's get on to it. The microserver serving as the ventilation, as the air vents. This is the DC motor connected to a 12-volt power supply, simulating the water pump. We have the frost sensor to detect rain, the soil moisture sensor to see how well the soil is, how wet the soil is. Then we have the photoresistor detecting light, and we have the TMP36 temperature sensor. So let's start. Here's the code. It's in the PDF, it's in the report, and let's start simulating. So based on the code, we have thresholds. So if this threshold is based on the condition, so let's say this is the temperature threshold. If the temperature is less than 30, the air vent will be closed. However, if it's more than 30, then the air vent will be opened. So right now the temperature on the LCD screen is showing 24 Celsius. If we increase the temperature to 57, meaning it's more than 30 degrees, you can see the air vent is opened, and vice versa. If we decrease the temperature, the air vents will be closed. Alright, so that's done with the air vents. Now we move on to the soil moisture. The light sensor for the LED will do that last because that requires 30 minutes, and I'll just edit the code to show you that it is working. So for the soil moisture threshold, it is 500. As you can see right now on the LCD screen, S representing soil is at 0. So that means our water pump is working since there's no moisture in the soil. So if the moisture in the soil is more than 500, so let's say 643, you can see the water pump it's not working, it's turned off. Again, if I were to lower the soil moisture right here, and then the water pump starts. And let's say that the soil moisture is 0 and it starts raining. The rain threshold is 100. So if the rain exceeds the threshold right now, it exceeds 100. So that means the water pump automatically turns off, even when the soil is at 0. Okay, and if I were to put it back to 0 for the first sensor, the rain detection system, the water pump turns back on. So that is the rain failsafe system. And lastly, we'll move on to the light. So the light system, the light sensor, the light growth LED, will only turn on when there's no light for 30 minutes. So we cannot simulate that. I'm not going to wait here 30 minutes, so we'll just edit the code to, that's 100,000 milliseconds, so we'll just change it to 6,000 milliseconds, which is around 5 to 6 seconds. And let's start the simulation. The system boots up around 2 to 3 seconds, and then we'll wait for it to light up. And the LED lights up, meaning that there isn't enough light in the greenhouse system, indicating, yeah, the LED is indicating that isn't enough light. So that's that. Let's change that back to 180,000. So that's 30 minutes. Okay, and that's that. Thank you very much.